Welcome back. In this video, we learn an example for perceptron. Here, we try to represent a Boolean AND function. First, we initialize the values. The weights are initialized as W1 equal to 0.3, W2 as minus 0.2. The learning rate is defined as alpha equal to 0.2. The threshold is represented as theta equal to 0.4. The input can be either 0 or 1 for x1. Similarly, for x2 also, it can be either 0 or 1. The activation function here we use is a step function f of x. It means that the perceptron fires either a binary value 0 or a 1. If the value of f of x is greater than or equal to 0, it outputs 1, or else it outputs 0. Here is a representation of a Boolean AND function. For Boolean AND function, it takes two inputs x1, x2, and the desired output is given as y desired. So it can be 0, 0, the output is 0, 0 and 1, the output is 0, 1, 0, the output is 0. If both values are 1, then the output is 1. This is a normal AND function. Now we need to apply all the 5 steps in the perceptron algorithm. So in the first epoch, we learn what is an epoch. One complete pass of the entire training data set through the learning algorithm is said to be an epoch. For example, you consider a training data set which has 100 samples. In one epoch, the perceptron will see all 100 samples once and update its weights based on them. For example, if you are training for 5 epochs, the perceptron will see those same 100 samples 5 times, adjusting weights each time. Why these epochs matter? Consider we are keeping only very few epochs. It means that the perceptron might not learn enough patterns and it leads to underfitting. Consider we are training with too many epochs. Then it might memorize the training data and it leads to overfitting. Often learning rate and epoch count work together to control how quickly and well the perceptron converges. Now we learn what happens in this first epoch. We know the input. The inputs are x1, x2, and we know what is the desired output. The desired output is given in the third column. Then we need to calculate the weighted sum. Weighted sum is nothing but x1 w1 plus x2 w2 minus the threshold. Now we need to calculate if x1 is equal to 0 and x2 is 0, then how it looks like. x1 is 0 into w1 is 0.3 plus x2 is 0, w2 is minus 0.2 minus theta. Theta is 0.4, which is equal to, when you calculate this expression, you get minus 0.4. And then we calculate y estimation. What is this y estimation? Y estimation is nothing but from this value you apply the activation function, step function. When you apply the step function, this is less than 0. This minus 0.4 is less than 0. So the step function produces the output as 0. Then we calculate the error. What is the error? Here the y desired value is 0 and y estimated value is 0. So the error is 0. Okay. And there is no change. It means that the weight is the same weight. W1 is 0.3 and W2, the weights are not changed. So W2 is minus 0.2. Similarly, we do for x1 equal to 0, x2 equal to 1. Now we calculate and we found out that weighted sum minus threshold as minus 0.6. And now we apply the activation function. This is the negative value. So the activation function produces a value 0. Now we find out the error. What is the error? Error is the difference between y desired and y estimation. The error is 0. Both are 0. So the error is 0. And so there is no change in the weight. So there is no change in the weight. Similarly, we calculate for the third row, x1 as 1 and x2 as 0. And here the y desired value we have is 0 and y estimation we get is 0 and the error is 0. There is no change in the weight values. Now for the final row, we calculate x1 as 1, x2 as 1. When we calculate, we get minus 3. Minus 0.3. When we take the step function, it produces the y estimation as 0. But the desired value is 1. So the error we get as 1. There is an error. We need to update the weight values. Already we have seen the formula how to update the weight value. First, delta of W1 we need to find out. Delta of W1 is equal to alpha, which is the learning rate, then E of t, which is the error, into x1. So which is equal to 0.2 is the learning rate into error of t is 1 into x1 is 1. We get as 0.2. Then we need to find W1 value. W1 equal to W1 plus, already we have the W1 as 0.3 plus delta W1. Delta W1 is 0.2. So 0.3 plus 0.2 is equal to 0.1. Similarly, we calculate delta W2. Delta W2 equal to learning rate into error into x2. Learning rate is 0.2, error is 1, x2 is 1. So we get 0.2. Then we update W2. W2 is initial W2, which is minus 0.2 and plus delta W2. The delta W2 is 0.2. So minus 0.2 plus 0.2 equal to 0. The new weight is 0 and there is a change. If there is a change, we need to go for the next epoch. We will find out the next epoch, epoch 2. The same way we calculate, we have x1, x2, y desired, x1 0, x2 0, y desired is 1. If both values x1 and x2 are 1, then y desired is 1. Then again we calculate, we get the y estimation for 0 for 0 0, y estimation for y estimation as 0 for 0 1, y estimation as 1 for 1 0, and there is a error as minus 1. And here also there is a error between y desired and y estimation. So there are two changes. So we need to update weight W1 as well as W2. How to update? The similar way, delta of W1 I will do for input 1, 0. You can practice for another one, the next one. Now delta W1 is equal to 0.2 into minus 1 into 1 equal to minus 0.2. Then we substitute and we find W1. W1 we find as 0.3, which is written here. Now delta W2, we need to find delta W2, which is 0.2, learning rate is 0.2, the error is minus 1 and x2 is 0, which is equal to 0. We find W2, what is W2? We get as 0. W2 is 0 here. Similarly, we update the weights for 1, 1. We update the weights for 1, 1 and then we get the weights as 0.5 and 0.2. There is change in two rows. So we need to go for next epoch, epoch 3. Epoch 3, we start with epoch 3. Here the weights are 0.5 and 0.2. With this we are starting out. Okay. Now we calculate, and here you can see in this case the estimated output is the desired output is 0 and the estimated output is 1. So there is a change, there is a error, so there is a change. In all others there is no change. So we need to update the weights. How to update the weight? We calculate again delta W1, W1. Similarly, delta W2 and W2 we calculate, and we update the weights as 0.3, 0.2. Since there is a change in this particular row, we need to go for next epoch, epoch 4. We do epoch 4. We start with the weights as 0.3, 0.2. And then we calculate, and we are getting the estimated output as 0, 0, 0, 1. 1 is if both x1 and x2 are 1, the desired output should be 1. Here also it is 1. The remaining values are 0. This satisfies the AND Boolean operation. So therefore, in the fourth epoch, the perceptron learns and gives the desired output for the Boolean AND function. This is how we work with a problem in perceptron. Similarly, you can do for other linear separable problem. A perceptron model can solve any linearly separable Boolean functions. For example, consider an XR. XR is not a linearly separable problem. It is actually a non-linear separable. It means that if x1 and x2 both are 0, then it produces 1. If x1 is 1 and x2 is 1, then it produces 1. Otherwise, it is 0. It means that it is a non-linearly separable problem. Hence, for this kind of problem, the single layer perceptron cannot classify it properly. Therefore, there comes the evaluation of multi-layer perceptron. Thank you.